Good morning, students. So, as we have discussed in our syllabus part, all the topics how we are going to cover up. So, our first topic for chapter number 1 is electric charge and electric field. So, in this chapter, it is a basic introduction of all those topics which we are going to cover up in your future syllabus classes. It has certain definitions. We have been given all the definition part and some basic theorems and laws. So, firstly, what is electricity? You know what is electricity? It is a term as energy. What is energy means? It is the energy of attracting things. So all those substances which is producing are showing the properties of attracting things, and its sort of phenomena is called as electricity. Now electricity is always acting on some area. So the substances on which this property is being applied is called as electric field. After electric field, we have to know how it is being caused. So its cause is basically the charge. That is the electric charge. So what is charge? Electric charge. It is defined as it is a physical quantity. A physical quantity which, when joined by a substance, means suppose if you are having a physical quantity, a physical quantity which you can see, you can touch, you can feel. When it is joined by a substance and the substance becomes electrified. Suppose if you are a human body, as being human being, if you are going to touch a open wire, which also we should not do. So after when suppose a current wire is on, a switch is on, and you are putting your finger inside the that switch. So what will happen? After some time you will be seeing yourself flying on the floor. Why? Because you are getting electrified. Our body cannot sustain those powers. Means human body is a great source of conduction. So it shows that how the electric charge is being produced. Means any substance which when it is joined by an electric charge substance, that becomes electrified. Now it is a scalar quantity. Scalar quantity means, as we have discussed in class 11, scalar quantity are those which have only magnitude but no direction. So it has only some magnitude, it has only single value, and it has some SI units. So SI unit is coulomb, 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 and it is denoted by C. Its dimension formula is, you can go for its formula. I will explain it later. Its formula is M0L0TA. T stands for what? Time. A stands for current. A, ampere. Again, electric charge is being distinguished in two different parts: positive and negative charge. Positive electric charge and negative electric charge. How it is being defined? So positive charge is defined as the charges which are produced due to the loss of negative charge. So when there is a loss of negative charge, positive charge is produced, and its opposite, negative charge. How we are going to define negative charge? Means the charges which are produced after the loss of positive charge. So when there is loss of negative charge, positive charges are produced, and when there is loss of negative charges or positive charges, negative charges are produced. So it is vice versa. Again, this is a basic introduction. After that, we are going to start the electronic theory, how the matter speaks out in terms of electronic theory. So first thing is that we know that every atom has a nucleus. Every atom has a nucleus, and inside nucleus it is consists of proton and neutron. And now we know something about that proton is positive charge, neutron has a neutral charge, and there is one more particle, that is electron, which is continuously revolving around the nucleus inside the atom. Inside the atom there is nucleus. Inside the nucleus it is proton and neutron. Proton is stable, it does not move, it is very static, and electron it revolves around the nucleus. So these things are basic for the electronic theory. Now again we have some definitions. We should know what is conductors. What are conductors? Means the substances which allow the electric charges to flow through them are called conductors. The basic examples is silver, metal. Our beads of human body is a basic very good conductor of electricity charges. Then there are insulators. The substances which do not allow, they will not allow any charge to flow through them, is called as insulator. Insulators, if examples as you can see, wood, rubber, glass, plastics, so many things are there. Now thirdly, we have semiconductors. Semiconductors means its property lies between the conductors and insulators. Means it has conduction value less than conductors more than insulators, and it has some insulation property also which is higher than insulators and lower than conductors. So we can see that semiconductors property lies between conductors and insulators. And its examples, basically we know generally we use two different semiconductors. First is silicon, second is germanium. Now there is one simple term always we are going to we hear in our day-to-day life, that is earthing. What is earthing? Earthing means, suppose if you have to transmit a charge to the earth. So what we do, we take a wire or running electricity wire and we put inside the ground. This thing basically at our home during the construction time, it happens when the electrification works is being done. So what they do, they initially they put that wire inside the ground, which we cannot see after all the flooring work. And one more example is that of the tire of aeroplane. On the tire of aeroplane, when it lands, so on the landing, basically it gets electrified, it gets charged. So what the engineers they have done, they have designed such a way that it's designed that all the charges are being distributed to the ground. So they have provided earthing to the tires. Now the first basic introduction about induction. You know what is charging by induction? You know what is charging for all the mobile phone charging, laptop charging, all these things. So how that charging is done by induction? Induction is a process to induce to get the property, to absorb the property. So this thing we can learn by taking certain example. Suppose if you take a substance on an insulator stand, which is being we don't know about whether it's charged or not, and we take another substance and we know that it is a charged substance close we take close to the uncharged substance. After some time what will happen, that they are going to arrange themselves according to their orientation. Means the charges which are the surface which is closer to each other, they generate the opposite charge. And the charges at the surface which we are having at the far end will generate the negative charge, means opposite charge. So in this way we can learn that, we come to notice that if you want to take a screenshot, you can take a screenshot. I will pause for a second. So we can continue after this. So again we have for this charging by induction, there is an example, gold leaf electroscope. This electroscope, what it does, it is a device to know whether any substance is charged or not. This electroscope, what it does, this apparatus is used to detect the presence of any charge on a substance. Any substance, अगर उस substance पर कोई charge होगा, तो ये electroscope उसको identify करेगा. Now we are going to study the basic properties of electric charge. It has three different properties. First is very important, conservation of charge. Second is the quantization of charge, and third is the additivity of charge. Conservation, quantization, additivity. These three are very important properties for exam point of view also and for learning point of view also. The first is your conservation of charge. Conservation of charge can be learned by, and according to this principle, what will happen? The net charge, the net means total amount of charge present inside a substance or an isolated system. Isolated system means, suppose this chalk is a substance, suppose it is a substance, and if I am putting it like this, so and I am not letting any other substance to go near this, so this thing can be termed as isolated. So any isolated system, inside that the net charge present inside it always remains constant. Means the charge never changes its orientation without any external pressure. Means if it is an isolated system, there is no charge movement inside without any external movement. Now secondly, we have quantization. Quantization means what? That the charge present on a body, is always the integral multiple of all the charges. Means integral multiple means, suppose if it is a body, if you take a substance and it has some charge like plus electron, plus 2 electron, minus 3 electron. So all these things plus minus means it is an algebraic sum of all the charges present inside the substance. Q is we define it, we show it by Q. We denote it by Q equals to plus minus NE. N stands for any number 1, 2, 3, 4 up to infinity. Means when you add all those numbers algebraically, so I have written here plus minus. Okay. So first was conservation, second was quantization, and third is additivity. Additivity of charge is defined as the total electric charge. The total electric charge on an object is equal to the sum of all the charges present. Simply, we can say the property of electric charge is that always it has a property to add itself. It never subtracts itself. Algebraic sum, we have understood that it has algebraic sum, and additivity shows that you add all the charges present inside the substance. If a substance has so many charges at every corner of its area on the surface, so what will happen? You add all the charges. We never subtract, we always add the charges. These, after learning all these things, we move on to Coulomb's inverse square law, which will be very important for exam point of view. Coulomb's inverse square law. This inverse square law, the name itself suggests that there is something inverse square. So the force, the electrostatic force that is present inside any charge, the force with which a charge moves inside that field. So that force is always proportional to the multiplication of charges. That is, suppose if you take two charges at these 2 points, these two charges are at a distance of r. The distance is r, and these two charges are suppose q1 and q2. So these two charges always get multiplied. The force is directly proportional to the multiplication of charges, and secondly, it is inversely proportional to the square of the distance between them. If we are saying inversely proportional, so after proportionality sign we have to put 1 by. Okay, so it is termed as inversely proportional to r square. Or if we change the way of speaking, so we can say proportional to 1 by r square. So inversely proportional itself suggests that it is 1 by. So when you combine both the equations, we get force proportional to q1 q2 by r square. Now after removing this proportionality constant symbol, we get here k. K is a proportionality constant. Its value is denoted by relative permittivity. It is called relative permittivity. The relative permittivity is the ratio of the permittivity of any medium divided by the permittivity of free space or air or vacuum. So K is the constant which we have in place after removing the proportionality constant symbol. K, its actual value after some practical experimentation, they have given a value 9 into 10 to the power 9, or in terms of mathematically, if we go to its value 1 by 4 pi epsilon 0. Epsilon 0 we have already termed as it is the permittivity in free space or vacuum. So by putting the value of K in this equation, we get F equals to 1 by 4 pi epsilon 0 Q1 Q2 by R square. So this Coulomb's inverse square law is very important for your exam point of view. Its statement, it states that the force of attraction or repulsion, always if the charges are same, they will repel. If charges are in opposite, they will attract. The force of attraction or repulsion between the 2 point charges. Point charge means its magnitude is very small. 2 point charges is equal to the product of their magnitude and inversely proportional to the square of the distance between them. So mathematical derivation we have seen here, F is equals to 1 by 4 pi epsilon 0. It is the final equation. F equals to 1 by 4 pi epsilon 0 Q1 Q2 by R square. So there is one more definition about unit charge. What is unit charge? Unit charge is a thing that if two like charges of equal magnitude, equal magnitudes are placed 1 meter apart. Suppose if we are taking these two charges and R is equals to 1. If R equals to 1, if you put here, then what will happen? That it will show a force of repulsion of 9 into 10 to the power 9 value. Force, Newton. 9 into 10 to the power 9 Newton. Suppose if two charges of same magnitude are placed at a distance of 1 meter, suppose this distance is 1 meter. So the force which is being produced between these charges मीन्स जिस फोर्स से एक दूसरे को खींचेंगे या अट्रैक्ट करेंगे या रिपेल करेंगे, वो फोर्स का वैल्यू कितना होगा 9 × 10⁹ न्यूटन. सो अगेन relative permittivity we have seen K equals to epsilon, R equals to epsilon by epsilon 0, and we have some limitations of Coulomb's law also. Limitations of Coulomb's law is that this law is true only for the point charges. It is only for the point charges. Secondly, it is only for stationary charges. For dynamics, it will not be allowed. And thirdly, it has not true for very large distance. Suppose if this R becomes very large, this law becomes inapplicable. We cannot apply this law. After that, in the next discussion, we are going to deal with the principle of superposition, and also we have some distribution of charges. So right now only this much for this video, students. Thank you. You can pause the video and you can